Hi, I'm Dr. Karen. Today we're going to talk about one of my favorite subjects, the Aurora Borealis, also known as the Northern Lights. Let's start by looking at a few pictures. One thing we notice on all those pictures is the predominant color of the aurora is green. There's some red at high altitudes, but it's mostly green. So what causes it to be green, and what causes it to be red, and what causes the color separation? To answer these questions, we need to know something about the atmosphere where the aurora occurs. Now, the lower edge of the aurora is at about 100 kilometers. That's about 60 miles up. We call that the edge of space, or the ionosphere. Up there, the air is different than it is down here. It is very much thinner, and it is layered based on the mass of the particle. Notice I said particle, not molecule. Molecules are too heavy to reach that altitude. So we're looking at atoms, primarily nitrogen, oxygen, and helium. Here we've got a little bit of a graphic. From about 90 kilometers to about 100 kilometers, we have atomic nitrogen. From 100 kilometers up to about 500 kilometers, where the aurora occurs, we have oxygen. And above that, we have hydrogen. Okay, now we know the structure of the atmosphere and that the aurora occurs mostly in areas with oxygen. So how does that give us the red and green colors? Well, in a previous lesson, we learned that activity on the sun results in an electric current going through our upper atmosphere. Those electrons come in and hit the oxygen atoms. They're very energetic and they hit a number of them. It's just like bing, 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 like a pinball machine. Okay, they excite the oxygen atoms so the outer electron jumps to a higher energy state. Now, oxygen has two primary energy states, surprisingly enough. We've got the ground state, we've got the state that gives us red light, and the state that gives us green light. So that's where the red and green come from. So why are they separated? Well, we might first say, well, maybe it's because there's more lower energy electrons at higher altitudes. That's not quite correct. Actually, it turns out that the percentage of red and green excitations is pretty constant. So we've got red and green mixed together. There's a lot more red than green. What actually makes the difference is timing. What happens is, when an atom is excited, it sits there and vibrates for a certain amount of time before it lets off the photon and goes back to its ground state. If it's vibrating and something comes along and hits it, it loses that energy and we don't get the light coming out. We call that collisional deactivation. So, the amount of time that red state has to vibrate before it lets off the light is about 2 minutes, which is close to forever up there. We need to have 2 full minutes between collisions of particles in the atmosphere. And that just doesn't happen unless you're really, really high up where the air is really, really thin. That's why the red only shows up at high altitudes. The green, however, only vibrates for 0.2 of a second, which means the atmosphere has to be really much denser to collisionally deactivate the green state. So what we've got is the red and green come from different energy levels of oxygen, and the red takes longer to emit, so it gets deactivated faster. at lower altitudes. The aurora, in addition to providing a light show for us, tells us something about the atmosphere. Thank you.